Hello Lemobit students. In this tutorial, you're going to learn about Java streams. Yep. So let's go straight to the point. Let's say you had a list of values. Let's say a list of integer. What? A list of integers. And let's say this integer saved scores. So let's say we had a list of scores over 100. Let's say 34, 45, 12, 3, 7, 99, 46, and 72, 64. So we have about 3, 6, 9. Let's make it 10. So 87. So we have 10 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So we have 10 integers in this list. And I want to work with this list. So I want to do some operations on the values in this list. In the traditional Java, what you could have done is use a for loop and loop through it. So let's say I give a question to print out only the even numbers in this list. So what you might do might be a for each loop. So for each loop, for each integer in scores, you come in and you check if that integer modulus 2 is equal to 0. What this does is it divides the value by 2 and returns the remainder. So any number divided by 2 that has no remainder is actually even because it divided perfectly. So for each integer in scores, check if it's even, and if it's even, you print it out. I can say found an even number. I do this and I add the number. Yeah. So we can run this, and I know that 34 will be printed out, 12 will be printed out, and let's see. So yeah, 34, 12, 46, 72, and 64. So that is the answer. So let's make this a little more complex. Of course, not like complex, but let's add another question to it. So let's say you want to find all the even numbers, then add 10 to them, and then check the ones that are less than 20. So for example, we have checked for the even numbers. Therefore, each even number will add 10 to the even number. So x is equal to x plus 10. Then after adding 10 to it, if x is less than, let's say, 50. So if x is less than 50, then we'll say found suitable number. So what are we doing here? We are checking for even numbers, adding 10 to the number, and checking at the end if the number is less than 50. And as you can see, adding those two criteria just make this look more complex. Now the code is expanding, and if you add more questions, it will keep expanding until you might get lost in the for loop. Java streams represent a sequence of elements. So as you can see, this list of values from 34, the first element, down to the last element, which is 87, we can make this into a stream of data and then process it in pipeline operations. So let's get to the code so that you understand what I'm saying. So if I want to convert this list into a stream, all I do is scores.stream. So now it's a stream of data. So what should I do to the data coming in? I can say for each so at the moment I'm saying convert this to a stream, and for each element in the stream print it out. Now if you're familiar with lambda expressions, you shouldn't have any issue with this expression. This is saying that for each element that is coming, I'll call that element integer. This can be any name. I can name it VV, but I'll come here and call it VV also. So I'm saying for each element that comes here, I'll call that element VV. What should I do to that element? Print it out. So by the time I run this program, it will print out each element in this list. You can see what was performed by the code, just as we said. Now perhaps we want to do some operations on these elements before printing it out. Remember when we filtered for even numbers? So as the numbers are coming, I only want even numbers to be printed out. Numbers that are not even should be discarded. So before the for each, I can add what I call filter. So for each value that comes in, I call that value integer. I can call it any name. If that value is even, allow it to pass. So for each value that comes in, what criteria does it have to satisfy before it is filtered? Now here is the criteria. If that value is an even number, allow it to go down. So I told you this is like a pipeline. Think of production line. You know the way they make cars and the parts move from one robot to the other. So each robot has a function. So also in streams, the data comes down like a stream of data. It comes down and it can operate on it step by step. I can add more steps before it finally reaches down. So it comes down step by step and I operate on the data at each level and get the information I need from that data. So in Java streams, if you want to filter anything, you can use the filter value. So now let's say our filtered values that are even. After filtering values that are even, let's say I want only even numbers that are greater than 20. So if you look at this, or let's say even numbers greater than 40. So if you look at the even numbers here, let's run this first and look at the even numbers. So here you see some even numbers: 34, 12, 40, 72, and 64. So you can see that it didn't print out all the numbers as it did before. So right now, after printing out even numbers, I want to filter it further I only want even numbers greater than 40. So what do? I have two options. I can add another filter below. So after filtering what is above, come again and make sure that that integer or that number is less or greater than 40. So we'll run this again. As you can see, it printed out only 3 even numbers, even though we have more than 3 even numbers here. But after filtering the even numbers, it came down and then filtered only even numbers that are greater than 40 and then printed it out. We could also use the AND operator. So instead of doing 2 filters, I can come over here and say filter values that are even and greater than 40. That works as well. So if we run this also gives us the same results. No problems. So if we go back to our first question, after filtering even numbers and then we have even numbers greater than 40, let's imagine that we want to add a value of 10 to each of them. So after filtering them, we want to add 10 to 46, 10 to 72, and 10 to 64. So there is something called map in JavaStream. So call it map. So what map does is that it operates on each of the elements that comes to it. So in this case, I can call each element integer. So for each integer that comes here, add 10 to it. So integer plus 10. Then when it comes to the for each, it prints it out as well. I can call this t, and I run this program. So we'll have 56, 82, and 74. Remember what we had before? If you look, it added 10 to each of the values. If you look at the output, you will notice that they are not arranged or sorted. So you have 56, 82, and 74. So let's imagine we wanted to sort it ascending order. We could come here and write sorted, and that's all. So we have 56, 74, and 82. Now, ain't that cool? To me, that is awesome. You know, imagine if we wanted to do this with if statements and for loop. I don't think it will be 5 lines because everything we've done here is about 5 lines of code. I don't think we'll use 5 lines to execute that with for loops and if statements. Now there's something I would like you to take note of. For you to work with streams, you don't always need a collection. You don't need to work with a collection such as array list or arrays. To work with streams, you mustn't always use a list. You could generate a stream of values from the stream class using some methods. So for example, let's say I want to generate a stream of numbers from 1 to 5. I could simply say stream dot of. So stream of 1, 2, 3, 4, 5. and there we have it. I can say filter all the integers that are less than 4 and please print them out. Yeah, so this will print out 1, 2, 3. As you can see, it will print out 1, 2, and 3. So for here, you can see that I generated quickly some values and I am working with them. So I didn't need to create a list and then come and change it to a stream. I could simply use this. If you have worked with RX Java, this is very similar to the structure of RX Java. Now, let's say we want to work and perform some operations on this. I could use my map. So for each value that comes here, let me multiply that value times 2. So we would have 1 times 2, 2 times 2, 3 times 2, 4 times 2, 5 times 2. Now, let's also convert each value. So we have this. So I run this and it gives me 2, 4, 6, 8, and 10. I could as well create a stream of strings. And 5. The only difference here is that I can't multiply a string by 2. If you look at this, it says the operator cannot be applied to string. Java already knows that what is coming down is a string. But I could do this. I could map and say for each, give me the length of that value. So what is going to print out now is to print out the length for each value. And of course, the length of all these strings, they are all 1. You can see how we're using map here. But what if these values were actual scores and I wanted to perform some mathematical operations on them? I would have to convert these numbers, or currently these strings, to integers. So remember that in Java, if I have a string, let's call it string x, and it has a string value of 99, I can't come and say int y is equal to x times 2. The reason I can't do that is because currently x is a string and I can't come and multiply 2 by a string because this string could be anything. I can't prove that it's a number. If I want to perform this operation, I have to convert this to an integer. And the formula, I'm saying formula, the method to convert this to an integer is integer.value of x. So once I get the integer value of this string, I can now multiply it by 2. That is what we're going to do over here. So right here, what I'm doing, I'm getting the length of the string. But for every string, I can't say multiply the string times 2. This is because what is coming down is a string and we can't multiply them by 2. So before the string comes down to this map, let us convert it to an integer above. Map to int. So for each string that comes here, give me the integer value of that string. As you can see, after doing that, the error here goes. But there's a shorter way to do this. If you're experienced with lambda expression, I can come here and do this. It's method reference. It's still part of lambda expressions. So once you pass down, now multiply it by 2 and then it goes down to for each. So for the first value, it will be a string 13 that comes here. It is now converted to an actual number, which is 13, the integer. Then it comes over here, 13 times 2, which is 26, right? It's 26. So after that, we come over here and print it out. So when we run the program, you see 26, 46, it is 66. And then that's it. But assuming we remove this map to int from here, there's going to be an instant problem because we can multiply a string by 2. But putting that there, we can sort it out. So perhaps we wanted just one number. Let's say we wanted to convert everything to an integer and then find the number with the highest value. So after multiplying it by 2, we want to find the biggest number. We can just say max. Then if present I. So what does this do? I convert this to integers. I multiply all of them by 2. And what this is saying is find me the maximum value from this stream of integers. And this if present is saying if there's a value like that. So if you go to the documentation of if present, you will see that it is called if a value is present, if it exists. So if there's actually a maximum value from a stream of elements, we print it out. We can also shorten this to represent something like this. So system.out double colon and print line. It's saying for any value that comes here, please print it out. So when we print this out, what do you think the maximum value is? 66. Yeah. So it gives us the maximum value. Do you see how nice this is? Now, let's say we didn't want the maximum value, right? We wanted to, let's reverse to how it was before using the printout. Now, we can also shorten this to that since you're used to it now. Converting a string to integer, multiply by 2 and print out everything. But the issue here is when we print it out, it is not sorted. So we have 26, then 46, 66, 48 and 30. Yes, it follows the sequence of the stream, but what if you wanted it to be sorted, arranged from, let's say, ascending order? You can come here and write sorted. And I have sorted out the list. You know, I didn't need to do any fancy for loop or if statements. We just sorted it out using one line. And Java has made it efficient so that there's no wastage of computing power. They have made it as efficient as possible. So you're advised, if you want to do something like that, you can use this. They have really battle tested it. So if you wanted to create a stream of integers, purely integers, there's a way to do it. You want to create a stream of primitive data values like integers. You could use what we call Intstream. Intstream of can give it a set of values 1, 2, 3, 4, 5, 6, 7. So Intstream of 1 to 7, and then I want to map it. So I'll say the map. So I can say for each value that comes here, multiply it by 5. And for each element, we can say I. So for each element, print it out. We can shorten this, like I said. I think you're more comfortable with this. So get me values 1 to 7, multiply them by 5. Now print out the values. And you see, we've done that. But what if I needed to use like a for loop, and I need values 1 to 99? I may not need to write this 1, 2, 3 to 99. That would be a long line. There's something called range. So I can say Intstream dot range. So I can say 1, 10. And we run this. So that is saying from 1 to 10, that is excluding 10. So when you say range, it starts from 1, but doesn't include the last element. So if you look at the documentation in range, when you see things like this and they say inclusive and exclusive, exclusive means it's not involved in that operation. So it starts at the first value, and then the last value is excluded from the operation. So if I say int range 1 to 10, it is actually 1 to 9. If I actually wanted it to do 1 to 10, I'll say range 1, 11. So that will be 1 to 11, excluding 11, which means 1 to 10. So when I run this, you see 5 to 50. So this could replace your for loops, easily with even, well, I say more power, because you have a lot of options here. So let's say you have 1 to 11, you have multiplied them by 5, and you want to find the average, right? You want to find the average, so you say average, and then if present, if any value is present from the operation, you can print it out. So over here, you see 27.5. You see how we made life easy? As developers, we like life to be easy. So this is quite nice. You could also convert an integer to an object. So let's say we had an Intstream, no, not that, Intstream range, let's see, 1 and 5 exclusive. Now I want to print out 1 to 5, but I want to have A1, A2, A3, A4, A5. So I can't do this. I can say map for each integer that comes here, A plus I. Now that won't work. Why? By the time this integer is appended to A, or A is appended to the integer, what we have is a string, not a primitive integer type. What we can do here is to say map to object. And then over here, we say for each value, I can say value, print out that value. So we can come over here and run it. So we see A1, A2, A3, A4. Yeah, A4. We stop at A4 because 5 is not included. Remember? So we have A1, A2, A3, A4. So we have map to object. So as you can see, this is really handy. So let's say we have a list. Let's say a list of integers, and we'll call it scores. Let's go to arrays, this list. So list of scores. So I have 34, 22, 25. No, blah, 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 blah. So I have a list of scores here. We have about 7 scores there. And let's work with streams. Let's see what we can do with streams. So let's say we have this list. I want to create another list from this list. And the list we want to create are made up of values here that are less than 40. So how do we do that? So first, let's change this to a stream of values. So scores the stream, and we'll come over here. So we filter each value. For each integer here that is less than 40, go down. So only elements less than 40 will progress. So once we go down, we can say collect collectors to list. So what does this command do? What does this command do? What it does is it gets the value here, and the stream of elements that arrive at this point are converted to a list. So the value it returns, I can put that value integer, let's say less than 40. Yeah, so I have a list of less than 40. No, let me make it scores less than 40. So scores less than 40, I converted scores to a stream, filtered the values less than 40, converted it to a list, and voila, everything is now inside this list. So I have a new list from this list. If you want to really verify what I just did, we can say scores less than 40 dot stream dot for each, and if we bring this out, we see elements that are less than 40, which are 34, 22, 22, and 11. So, and I'm printing from scores less than 40, not the original list. So we see that actually only the scores that are less than 40 were imputed here. So that way we can create multiple lists from one list easily using streams. Now you can do more with collectors. So let me give an example. Let's say we have a new class here. So a new Java class, I'll call it car. So we have a class car. A car has a name. So I'll say string name and int price. So I'll generate the constructor. Yeah, that's that. So we have the constructor and our variables here, name, price. So let's come over here and create a list of cars. So cars, I call it cars list. Let's go to arrays.asList. So I'll say new car. Which name we'll give it? We'll give it a name of Lambo and the price of 2,000. So there you have it. We have our car list. So we have about 5 cars here. We have Lamborghini, Ferrari, Toyota, Honda, and the Benz. So we have a list of values now, a list of cars. Now these cars are working on this class here. So when we come over here, you know that we can create a list, a stream of this list. So we can do a lot here now. Now we have a list of cars. Imagine you have an application that deals with, list of cars in the world, and you want to quickly sort through this list and filter the values. You can do a lot. So let's say we want to filter only cars that have a price less than 500. So, but before that, let's come over here. Let's have a toString method so that when we're printing it out, it comes out quite nice, of course. So let's filter this. So filter any car that the car dot price is less than or equal to 700. Now, for each element that passes that criteria, so for each car that passes that criteria, please print out the car. So we can run this program. So when we run the program, we see the cars that are 700 and below. And of course, our dear Toyota, very consumer friendly, and Honda and Benz. So these are the cars that are less than or equal to 700. Now, by the way, these prices are just made up by me, nothing really in those numbers, just for this tutorial. So we have all that set up. Now, let's say we want to find the average price of cars. So we can say, give me all the cars and then collect averaging int. Collect us the averaging int for each car. Use the price of the car to calculate this average, because this object is made up of name and price. So we're telling it that, okay, I need the average, but in this case, we're using the price to calculate the average. So what it returns now, it's a double. So we can come over here and say, print out the average. So once we run this program, let's see the average price of cars here. $940, $40, 40 pounds, 40 pillars of gold, don't know. And that's it to find out the average of a particular, using a particular value, because we could have price, we could have maybe number of tires, number of cylinders, we could find average of other elements. But in this particular situation, we're finding the average of price of cars. Now let's say you want something more comprehensive. You want a breakdown of the price. You don't want just the average. There's something called summarizing int. So if I say collectors.summarizing int, so give me the breakdown of the price. So what it returns, it's a int summary statistics. So what is this doing? It's getting the price and giving me all the possible requests I might need from the price. It gives me the sum, the amount of cars that have a price, the average, the maximum, the minimum. So we will see that now. So let me print out summary statistics. And we run that. Voila. So this is the summary statistics. This is the summary statistics for car. So we have 5 cars, of course. The sum of all the prices is 4,700. The minimum price is 500. The average, which we calculated before, is 940, and the maximum price, our Lamborghini, is 2000. So in case you wanted to get the summary quickly, you could do this. And if you wish to get maybe just one value, you could say get max, get average, get count. So you could pass this to a method. So assuming I wanted the count alone, I could just do that. And if I run this, you see I get only the counts. So this way I can just get the summary statistics, pass it down, and then I can get the values when I need, instead of querying the stream every time. So you can say that this is quite handy. So let's say we want to print out everything here in a single sentence, that is using the names. So let me print out something quite nice. So let me go here. So we can say car list dot stream. So right here, let's say we wanted to convert what we have here into a string. So we want to print out this as a sentence. So let's say I wanted to print out the cars we have are Lamborghini, Ferrari, Toyota, Honda, Benz. What do I do? So we convert this to a stream as usual. Now we get only the name. So for each car, give me the name. So we have our map. Then collectors.joining. What this does is that it gets these names, puts this as a prefix, as you can see. So it writes the cars we have are, then it starts adding and appending these names, and then separating these names using a delimiter, which I put as comma. So it will say the cars we have are Lamborghini, Ferrari, Toyota, Honda, Benz. Then suffix is what is the last string I should put there. I'll just put full stop. Now it returns a string which I saved in a variable called text, and I'll print it out. So by the time I run this, it shows you the cars we have are Lamborghini, Ferrari, Toyota, Honda, and Benz. Simple. So that's that for collectors.joining. So next, I'm going to talk on FlatMap. We already know what map does in terms of operating on a value. So if I have Intstream dot range 1,5, and I have the map, just map, man, just map. And we'll have map. So for each value that comes here, multiply that value times 2. Now for each value that comes down, print it out. It has a range 1 to 5. Now it maps each value times 2. And remember that this range is actually using 1 to 4. 5 is exclusive. So it does 1 times 2, 2 times 2, 3 times 2, and 4 times 2. And it prints out each value. Yeah. So looking back at where we were before, let's go back there. When we had our list of cars. So let's go back to our car class. Let's say we want to add one more element. And this element is going to be a list. It's a list of string, but it contains countries. So for each car, we'll list the countries where that car is being sold. So we'll add this also to the constructor. So now I can now come over to here. And of course, this guy will be crying. So we can create a list of countries. So I'll say, comma, arrays dot as list. So I can say USA, comma, China. So we have our name, price, and the list. So what do we do now? So let's create a stream of these values. So we'll say car list dot stream dot for each element. So once we run this, we'll get the values. So as you can see, we have our car. It has our name, price, and then the list of countries. What if I just want to work with the countries? So now if you look at this, what if I want a stream of countries in the different cars? So let's say I want to get this car, get the countries, get this car, get the countries, but I just want a stream of these countries, not the price or the car. What you may do mistakenly might say, okay, you want the car, then you want to get the car dot countries, and then you say maybe from here you can now say, okay, for each country that comes here, for each country that comes here, you want the stream of that country, right? So you say, give me the country of that car. Now for each country that comes down, give me the stream. Unfortunately, what you get is some nasty looking output. Not nasty per se, but then you're not getting a sensible output. What you need is FlatMap. What FlatMap does is, so FlatMap can convert each element of this stream into streams of other objects. So currently we have countries and we want a string of countries. Instead of doing map, what we need is a flat map. So a flat map, what we are turning back is a stream. So we have car, and then we're getting car.countries, but that's not what we want. We want a stream of countries. So we get dot stream, and it works. So for each car, give me the stream of those countries. So for each car, it gives the stream. So now we'll have about we have 5 cars here, and we have 3 countries each. So we'll have 15 countries coming as a stream of data. So when we run this, the first country is USA, and the last country is India. So if you see, it's not a stream of countries. So we have USA, Nigeria, India, USA, UK. Following is a stream of countries. So we just have a stream of countries from the car using FlatMap. I will link some articles below which you can, broaden your understanding on FlatMap. Let's say we have a list of numbers. So Intstream range. So I can say 1, 2, 3. Now, what does reduce mean? Reduces the stream of values to one value, depending on the operation you tell it to do. Let's say we have values 1, 2. Let me highlight it. We have values 1, 2, 3, 4, 5, 6. What reduce does is it wants to convert everything here to just one value, depending on what you want it to do. So let's say I give it an instruction that when you have a value A and a value B, add them together. So what does it do? It gets 1 and 2 and add them. So the value gotten from the addition here, which is 3, is brought over here. So we have 3 and 3. We'll add them together, 6. So we'll come over here, 6 and 4, 10, 10 and 15, 10 and 5, 15. Then we'll come over here, 15 and 6, 21. So what we have reduced is you have 2 values from we want to reduce everything to one value, but based on an operation. So let's say we have Intstream range. So we have 1 to 7 since we want 1 to 6, right? Over here we had the answer was what again? So this is 6, 10, 15, 21. So this is meant to be our answer. So we have range 1 to 7 and reduce. So we can have for each value a comma b, add a and b. So if present, print out value. So this is going to do exactly what we did over here. So when we run this, we should get 21. Yeah, and we got 21. Simple. So it gets 1, add it to 2, then brings the value to the next guy, add it, add it. If you are very sensitive, you find out that we can perform factorial with this very easily. For example, 5 factorial is what? 5 factorial is 120. Right? And how do you calculate 5 factorial? You say 5 times 4 times 3 times 2 times 1, or you can go 1 times 2 times 3 times 4 times 5. But basically, what you're doing is you're getting the value multiplied by the next value, the answer multiplied by the next value, and so on. So if you want to find factorial here, you could easily say, okay, I want 5 factorial, so int range 1 to 6. Because we're excluding 6, so it's 1 to 5. So reduce it using what? Multiplication. So you get the first value multiplied by the second value, blah, blah, blah. So what will output here is 120. Yeah, you see 120. So all the long story you've been trying to do to get factorial, we just did it using 3 lines of code. We could even shorten this. Let's say we want to make this very short. You know, you can even make it 1 line. Factorial. You see, Java is a lot better than how it was some years ago. You know, people always complain, oh, Java, long lines and stuff. But then with this, you can, you know, make your life better. So there are a lot of other cool things you can do with Java streams, but for now, I'll leave this here and you can go and search and, you know, learn more. If you did like this tutorial, give it a thumbs up and consider subscribing. See you later.